Okay. Well, this is going to be fun. So, yes. Yes. Hey there. Welcome. Welcome to the stream. Morning, NSA. Okay, well, we're gonna do this anyway. So, how's everybody going? Got some goals today. Are Windows 7 and 8.1 viable in 2023? As long as you don't need anything with AVX. I sure think so. Okay, so our goal is to rewrite the good morning, Gigo. Our goal is to rewrite the disk access code so UEFI can start easier. The way we're going to do that is just clearing everything out for now. Yeah. I'm just clearing it. I'm putting up a 4 terabyte drive because I don't want to dike in the snow. Yeah. That's fair. Yeah. I kind of figured you meant bike or something or walk. I was like, okay. Yeah, that's honest. Yeah, that's kind of shitty. Okay. I'm just gonna get rid of all of this. Illuminate what's inside. Oh. Okay, so I feel like there's a couple things we need to do here in order to do this correctly. I want to trace everything in this file. D. I'm going to trace a couple pieces of information here. Oh, whatever. Whatever. Okay, that makes sense. Why don't you use the function macro? ReactOS has its own way of doing things, and I don't really care to try and question it. So I just kind of follow whatever else happens in the file I happen to be working on in that moment. But yeah. Oh, yeah. I don't try to question these things ever. I probably should more, but... eh. Okay. New line and constant. Fuck you. Whatever. Okay. Cool. Right. The other thing I need to do is... Okay. That should do the trick for what I'm trying to start here. Let's enable all debugging. I would kind of like it if this thing worked like I expected it to. But I don't think that's realistic. So, yeah. Alright. So, when Freeloader boots up, it first starts the memory manager. It traces all of the memory and free in the system and blah, 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 blah. I've dealt with this many times, but I've become happy with how this works now. So, whatever. But, yeah. The next thing it does is it tries to find freeloader.ini, and if it can't find it, it'll put this message on the screen. Okay. So, the disk access code of Freeloader is objectively simpler than other bootloaders, but still pretty versatile. However, it's not really meant for what we're doing. So we gotta do a couple hacky wackies, if you want to call them that. Probably shouldn't, but I'm gonna call them that anyway. The first thing we need is to look at setup block devices and see what PC disk does. Or not. Okay. Initialize boot devices. Okay. Wow, I really don't. Yeah, I remember. A pointer of a boolean. Isn't that cute? Okay, so we have a buffer size, which is still the case here. The buffer page size, I just made page size, made it as loader temporary. Kind of simple, doesn't really do much. This enumerates the hard disks by trying to read the logical sectors of each device. We can say get hard disk information by passing a drive number, which makes sense, to be fair. This doesn't change much. Disk close, I mean, so we're just going to implement that really quick. Yep. The file information doesn't really change here, so I'm going to grab that as well. Disk open is the first one that really starts to change. If you notice, it doesn't do anything if we don't actually set up a list of boot paths, which is a little dumb, but it is what it is. Yes, it is. So the boot path doesn't here, I'm gonna actually I don't like that. Okay, the boot path takes in this freeloader boot path, which if I want to do this correctly, I think this is called first. I might be wrong, but I'm pretty sure this is called first. Is PXC is undeclared? I don't care. Oh yeah, PC sets the boot path on its own. It looks it up here. I knew that. No, I didn't. I didn't. I'm lying. Yeah, enumerates hard disk, sets the boot path, and finds if it's whatever, and tries to read it, and then registers it. Which I do it a little differently. I don't think there's anything wrong with that. Realistically, I don't want it to be statically like shoved into the arse of MBR, so that's how I do it. Okay, so this gets called first. This initialize boot devices, and then we set up the boot path after enumerating the hard disk. So 49 is the magic RAM drive. Doesn't really matter for UEFI, but we're going to keep this in here just in case. If it's less than 80, it's a floppy disk, which isn't really true because the floppy disk doesn't... You can't boot off a floppy disk in UEFI, I don't think. I mean, maybe you can, but I've never seen anybody do that, so we're going to remove that. Partition, if the freeloader boot partition is equal to 0xFF, then we, it's whatever. The problem with that is that in order to detect the boot partition, we have to force it to ask. So yeah. And it will fill it out that way. But that's terrible. So, yeah. That's just awful. That's really what I'm getting hung up on. But yeah. Okay, so if we look at it in UEFI, or not UEFI, if we look at it in this, okay, we'll find it eventually. Oh, no, we're not. We're literally not going to find it eventually. That is not something that's going to happen. I have no idea where this is supposed to be. Okay. So, it takes in a drive number, and it looks for the active partition entry. By reading the master boot record. So, that is not what we want to do, unfortunately. That is not how UEFI works. So, we're going to set this equal to 1 for now as a to-do. And if 0 this, yeah. we will have to create our own function to do this, which kind of sucks. So, yeah. I don't know how it's going to work with CD-ROMs at that point, but we'll see. Okay. Now we can take a look and see what this all does. Okay. It initializes the boot devices, allocates low memory, okay, whatever. Looking for our disk of whatever that number is because we took a negative number and that's really not what you're supposed to do. Okay. Yep. That's actually what I want. So, get partition entry. Yeah, so this is the function I was going to use to implement that originally. So, we're going to try to do this like Freeloader does. And following that logic, yeah, okay, a little closer to what I want. UEFI disk read is going to stay the same for now, probably. Okay. Get drive geometry. It clears the screen, sets up block devices, and then sets the boot path. Okay. That is what we're going to do then. So. Okay. We'll put this up here. Okay, so you might notice a couple sussies here. There's a lot of global variables in this fucking file. That is very much nothing that makes me very happy, but we're going to try to get rid of some. Probably. As much as we can, anyway. We'll try. Yeah, so UEFI disk open, I want to take a look at next. Okay. If it's a CD-ROM, sector size is 2048, which, okay. Dissect path will return the path. Yeah, so from here, okay. That way we'll have our drive partition, and it will get the partition entry, which, again, mostly normal. We only provide the block devices. So the only thing UEFI is caring about now... Hey, Winter, good morning. The only thing UEFI is caring about now is the base drive number on the arc path. It does not care about the partition. Probably. So if the partition is not equal to 0xFF, then we get that. Otherwise, we're going to get the geometry and set up the sector count. And then blah, 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 file system to get device things. This is a very standard function. This does not change at all. So, we want to keep that as close to UEFI disk as possible. That is my opinion. So, if we go back in here now, we'll have a couple new prints. Yep. Look at that. Okay, so now what we have to do is find a way to detect the next couple things. So UEFI disk seek and disk read are both different. The disk read takes a calculation of the total sectors and returns the offset. The geometry is round. Yes, it is. This is standard as well, so we do not do anything else with this. We're going to just copy and paste it. And then along with disk seek, which we need to update as it changes within ReactOS's freeloader. So that's fine, but we'll, for now, just pop that in here as well. So we can now seek and set up the drive geometry, just like freeloader does. The rest of this is now UEFI specific. So we've abstracted out all of the basic, all of the things that are staying the same. Yeah. So, yeah. Now we have to actually create some block devices, which makes sense. This is where we're going to do that, so I'm going to bore some space here so we can just look at this for a few minutes. Okay, the way I was doing this before, there is a lot of ways to handle it. I realized that one of the better ones is to actually just use the UEFI provided arc path. For now, let's try to get just the basic, block device in there. And then we'll go from there. So UEFI, or PR freeloader.efi. Wow, I don't speak that very well. Okay. Yeah, okay. We'll go in here. We'll go into UEFI. We'll go into UEFI disk. So I did this very simply. Not really, but it takes in a global system handle. Well, here. Let's use... I want to grab the actual one I was trying to use. So let's take a look. Oh no, I removed that. So wow. I have changed this a lot. Wow, I have changed this a lot. Oh god, no, I'm not doing that. Okay. Well, that's not what I was expecting. Not that I know what I was expecting. Okay. What time is it? Okay, we're still good. Okay. I grabbed a global system handle. We allocate memory for the pointer to the handles. This needs to be public. Keep up the good work, friend. Thank you. I will do my best. Yeah, so we allocate... I already found a bug in my old code. Jesus. This is really dumb. Wow. Wow. Okay. Okay. We're gonna fix a bug really quick, right off the bat, apparently. So, we have a dual while loop. Okay. And this is gonna take the EFI status. By setting status equal to 0. Oop. Status is that. So we first just off the bat do it once. Just locate the handle. And then while status is not equal to status success. Okay. So this is going to loop every time this is not successful, and then we'll grab this again. Okay? Pretty good so far. Now here's the thing. What we're doing is we're taking in the handle size. So we're allocating memory. Yeah? Yeah? Okay, but we're gonna have ulong count equal to 0 up here, and count plus equals 1. If handles is not equal to null, then we're gonna clear. I think that's possible, right? I don't actually know. I would assume so. It has to have something. Oh my god. Okay. Free memory. Okay, cool. free memory. So we don't leak data. If handles is true, free memory. Then we do it again. Which is this plus okay, there. So what this does is we grab the locate handle. We will get a size of a handle size. Sorry. And we will iterate and continuously allocate and free memory until it tries to get it right. So if we look at the way this works, we're gonna see the inside freeloader get hammered for a moment. Look at that. It works the first time. That's normal. I don't actually expect it ever to fail EFI size, but we don't know. So that's my error check. I just don't like leaking memory inside freeloader. That really fucks things up later, I've noticed. So this is our allocation. It is very nice, very good. I'm happy with it. So next, let's parse the fucking handles. There's a lot of information we need to know. For one thing, we'll have ulong I. Okay, cool. So we're gonna have a for loop. I is equal to 0, while I is less than the handle size divided by the EFI handle, which this is actually inside of parentheses because that is how I do these things. I heard this is better, so I guess we're doing that now. Cool. Okay. So we have, actually, let's say system handle count is going to equal this. I think that makes the most sense. That way we can have this nice, clean, just very clean for loop. Yes, very good. Alright, now we have this clean for loop here. This will run for every block device in the system. So, if in the event that we have a block device, which we should always have a block device, but, you know, I've seen some really buggy EFI implementations. And by that, I mean I've written one that doesn't have block devices and like properly working. So, yeah. Okay, so it sets up the handles by going into the pointer of handles and, you know, looks for the damn thing. So if it's unsuccessful, it'll skip over and go to the next device. Else, we'll print the BIO. Watch this. Okay. So now we'll go in through and parse. Watch how this works. Where? Ah. Okay. Now, you'll see some interesting stuff. You can see that we have set up block device, found a block device with size 2048, found a block device size 2048, and found a block device with size 2048. Okay. That is good. That is correct behavior right there. That is what we want. So this is a successful parse. It goes through the entire list. If I started adding disks to this, we would actually be able to notice them. So let's do that. Let's add some disks. Okay. Now, we should do some interesting stuff. For one thing, you notice now that the EFI block device list is way larger. Okay, we have 30 minutes left. Okay. Look at this. Now we can detect that we have many disks. Yeah. Okay, cool. It works. Now here's the deal. We have to add some stuff to this now, because that's not enough to do anything with. For one thing, there's a question that we have to ask. And that is, what is the public boot handle? So we're going to expand this a little bit. Public boot handle should be declared up here. So okay. Okay. Now, every device that we detect will be checking against this public boot handle, which is the device that was started by the system. Okay. Found a with 4. Oh. Yeah. So, setting up boot path, it found the boot handle with an offset device of 4. Which, if you noticed, is not correct for what we're doing. So what's happening is that it's going to the end of the ISO image because the thing that booted this was a tiny FAT32 partition inside the ISO. Essentially, the way ISO boot works is combining these little tiny partitions in one disk, and it's cursed. It works really well, though. It's just a little cursed to me. So we have to work around this. It's a little bit of a hack, but we're going to have to add it in. So the real boot partition is whatever this is. Okay. Whatever this is, we go back and we try to find the real, device. So, yeah, this is going to be fun. Okay, so this parsing code's obviously not super simple. It is not, does not follow the KISS protocol, if you want to call it that. Okay. All right, so we make this bigger. Okay, so on every block device, we want to read the MBR, but we're not going to do it like this I had before. Instead, we're going to make sure that it's a logical partition. So okay. Pretty simple. We just go through if it's a logical partition, then I want to trace. Because again, we want freeloader to handle this shit. Unfortunately. UEFI does a good job, it's just not the way freeloader works, unfortunately. Okay. Found root of drive 0, 1, and 2. Which... is that correct? Maybe. Yeah, maybe. we have a lot of stuff here. So we also want to check to see our block size. Okay, so make sure this is working so far. Okay, so we found a block device with the sector size 512, which we found the root of the drive with the sector size of 512. Good! Found a block device with the size of 512, found a root drive of 1. Good. Then we found the block device with the size of 2048, and it's the root drive. And then we find the partitions to the ISO, and then we found the boot handle, and then we find partitions to the ISO of, oh my god. Cool. I didn't know it worked like that. But yeah, anyway. So here is all of the devices in the system and their information. Okay, so now we have a way to detect what is a root block device. So now what we're going to do is add in the disk. Yeah? Yeah. So the way this works is we're going to get the hard drive information and read the MBR. By copying and pasting this. So yeah, here we go. It's literally going to take I plus 0x80, and that's really funny. Yeah. Yep, that's what we're doing now. Okay, it takes the disk V table, which makes sense, but actually not really. Because it's going to take the UEFI disk table. Yo, it's goofy too. Disk report error. Yeah, I guess that's not something we do, really. It's really goofy too, because the way this is, we can track and see what gets ran here. So, okay. Oh, look at that. That's so cute. Oh, man, that's adorable. Okay, this works like I want it to, actually. Very nice. This is exactly what I want. Okay, mock read logical sectors is what we're implementing next. Okay, we take in a drive number. Taking in the drive number. This works like I want it to. God, it's so cursed. Regional logical sector is unknown. Drive number 0x3. Zero x8. Okay. I know. I know. This is really bad. Yeah, I know. This isn't even like the final thing I'm going to end up having to do, which is worse. Okay. Okay. Okay, read partition from drive number 2. Yep. It gets even worse because this should actually like try to boot now. It's kind of funny. Oh, isn't that cute? Okay. That's actually working! What the hell? What the fuck? That is working really well. Wow. Wow. That's perfect. That is just perfect. It's exactly what I want. Wow, look at that. It knows what's MBR and not. It even can read the boot sector, which doesn't really matter for UEFI, but, you know, I don't really care. So, it's going to, as long as it's a valid partition table, it should load this. So, there's devices in here that don't have a boot sector. And it should still create the device. Registers device 0, register device 1, and register device 1 partition 2, register device 1 or disk 2. Okay, it is working. Exactly what I need it to. Okay, here's the problem. The boot partition doesn't have a very good identifier. So, we're going to have to do a little bit of... I think we're going to start by hacking it a little bit now. So our boot path is the partition entry, which we know is 0, right? Yeah. And then the drive. So the first step here is to set up the freeloader boot drive, which should be 2, 0. Okay. Okay. So instead of setting the boot path like that, we're going to actually set the boot path by copying over the freeloader boot drive, which is equal to 2. I guess 0x82, but hey, fuck you, I guess, right? And then 0. Yeah? Yeah. This should do something different. The drive number is 0. Get drive geometry 0. The file ID is negative whatever. But the path is correct. So it's reading from partition 0, which isn't true. But... yeah. The drive number is that minus URX80. Oh. That is not working like I want it to. Is it 3? I have no idea. I have no idea at all. ISO is just awful, man. Oh, it's reading... It's not reading it properly, that's why. Yep. See, look at that. That works. Okay, so now that it's a little less cursed, let's start by... Yeah, okay, so let's start by doing this. So instead of hard coding this to a value like freeloader does, I'm just going to make the sector size the block size, as I think that makes the most logical sense for the way this works. Okay, that's not really what I was expecting, but all right. Oh, that's why. See, aren't I adorable? Okay, that'll fix it. Oh, I did it again. What the fuck? Wow. Now, watch this. Right? Hey, look at that. Okay, well, actually, hang on. Let me make it more obvious what's happening here. Let me make it more obvious what's happening here. Okay. Yep, look at that. Freeloader starts now. Okay, so let me recap what's happening here. UEFI provides you with an abstraction of the block devices. The problem with this abstraction is that it doesn't give you direct access to the logical device. It gives you access to logical partitions. You can detect what's a logical device, though. So instead of us dealing with freeloader's partition management, the solution here was to allow freeloader to actually do its own work. The disadvantage is that we lose the ability to read GPT devices without implementing it into freeloader, but it means we don't have to rewrite a bunch of freeloaders code. So now what we have is that we can detect a list of devices. And if we go back in here, you can actually see this list pretty easily. It registers different devices and partitions for each device using the MBR format. For instance, the first partition being this or whatever, right? And in fact, if I really wanted to, I can actually set up a specific device to boot off of. So here's the thing. I have access now, or I have the ability to target a certain disk, okay? And we can target, let's say, I don't know, 8.1, yeah? It will choose the second hard drive, and it will try to boot it. And it will look for it, and it won't find it in this case, but yeah, that's the point. It'll try to look for it, okay? So if we load ReactOS, and we say 8.1, okay, which is the second hard drive, the active bootable partition is partition 1, and then the file system is ReactOS. It won't load the system hive, but it will try to read off the disk. The reason it's not loading the system hive is because there's nothing on that disk. But you can see it actually is properly reading it now. Yeah? Yeah, okay. So, yeah. Not bad. Not bad at all. So that fixes our partition management. Now, the bug is that we have to find a way, which I don't know if I'm going to do this today. I think I have to get to work, but we're going to find a way to take this hard-coded value and automatically detect it. The problem with that is that in order to do that, we have to find the root of the ISO drive. My thinking is that if in the event we can find the UEFI drive, yeah, halfway there, pretty much. That's exactly the case. We're basically halfway there. The basic functionality of disk management works now. It's just that now we have to find the actual boot device, if it's an ISO. If the boot device is a physical drive, then, well, it doesn't really matter as much. The USBs and stuff don't have this problem. It's literally only ISOs. That being said, indeed, we don't really care what's a CD-ROM or not. So that's kind of tough. For now, let's continue not caring about CD-ROMs, and I'm going to try to quickly put this one together before I have to get to work, because I'm all ready and stuff, so it should be okay. So we want to detect, when we parse through the block devices, if we have the public boot handle. And if we do, okay, if the public boot handle is not equal to a root drive, else if the current handle is equal to public boot handle, or actually let's say if the current I is equal to offset to boot. Okay. So if we're currently on this, then we want to stop here for a moment, and we're going to trace this way we can have an EFI partition that's on the other side of the disk. So, like, you know, CDs. Okay, let's make sure this is good. We can find this. If we can detect this, then we can keep going. Okay. So, attempting to find the root of the drive, we can see that it's the root of the drive's right here. We just need to go back to. This is very, very hard to do. So, what we're going to do, okay, is try to detect what is a root. So, if, do while the offset to, or bio is a logical partition is equal to false. We're going to adjust the boot handle to be whatever I is, or count, or increment. U long increment equals 0. Increment's going to then equal to offset to boot. Minus equals 1. Yeah, it's a little cursed, but yeah. Okay. And then we're going to try to find it. This is going to be equaling to increment. Hopefully to God, this will work. Illuminate what's inside. Okay, found boot drive. This. Here we go. This should always find the boot drive now. Please! It is as simple as I can make it. No. Wow, that just does not work well. Let's convert this into a while loop. So we'll offset to boot is equal to 1. If I is equal to the offset of boot,
Yeah, that's not correct. Oh my god. So while the logical partition is not even true. Oh! Okay. Wow. Wow, that was not super obvious to me for some reason. Okay. But still no... Oh, wait, I know. Maybe. No, I don't. Oh, you know what's happening? This is running through, and then it's not running again when this is actually hit. So all we have to really do is increment this one more time. Yeah, that makes sense, actually. That's logically not bad. Okay, so now... Yeah, it just needs to be one more time after that, because we don't run the loop if it's found. So now we actually find the boot drive. Okay, so... Okay. With any luck, it'll take the boot identifier. Right? Maybe, yeah. Okay. No more for loop. This should take the boot identifier. This should automatically detect if it's a CD-ROM. It won't find the partition if it's a hard drive, though, which is fine. We'll do that next. Yes? Yes? Yes! 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 Okay! Perfect! Okay! That works! Alright. Yes! That is just beautiful. Okay. That's what we want. Oh, beautiful. Okay, so... Now this boots. Now we need to find the hard drive. Sorry. The way we do this, if it's a partition... Yeah, if it's a partition... Yes, congratulations. Thank you. Oh, man. I think what we want to do is make the... If in the event where a removable media... Or actually, what we can do is we can grab the public boot identifier for UEFI, and essentially we can use that to detect the block size. Block size. May health to your hands. Thank you. We can use that to detect the block size. What are you doing here? And if the block size is equal to 2048, then we'll set the boot partition as as a CD-ROM, and we'll see what logic that makes it happen. Yeah, so okay. This will make it a CD-ROM. The problem with that is that if it's a CD-ROM, I don't know what value it's going to do. Found boot drive, opening file.ini. Oh, yeah, it needs to find it first, duh. Okay. Okay, this should be interesting now. Or it's just going to work. Okay. Oh. When will I be able to integrate it in an ISO file? It's already integrated into an ISO file. It's just not in master. I don't... I mean, I guess that makes sense. Oh. Yeah, that makes sense. Okay, so we need to do this. We're not done. But we are, however, done for now until I'm back from work. So I'm going to go ahead and end it here. Thank you all for watching, and I hope each and every one of you